In this challenge, we teach our robot how to go out into space alongside our pretend moon, circle around our pretend moon, and try to land safely back on Earth without being stranded out among the asteroids. First, we have to obtain our arena. Print out the images on page 23 and 24 of this document. Place the moon image, page 24, around a bottle or piece of wood. You may have to use sticky tape. Place your robot on your pretend Earth. The scene will look like the image below. To start up LEGO Robot Inventor, go to your Windows 10 Start icon and select the Mindstorms item. Click on it. Next, click on Code. Our first instruction to our robot is to teach our robot how to go forwards from our pretend Earth until it is roughly alongside our pretend moon. Take a ruler and measure this distance. In our case, it's about 23 centimetres, about 9 inches. To connect your robot to your computer, click on the icon with the small red dot on the top right of your screen, then click on Bluetooth, and follow the on-screen instructions to connect your robot to your computer using Bluetooth. Next, click on the Connect button at the bottom of the screen. You will now see that the icon on the top right of the screen now has a green dot instead of a red dot. The green dot means that your robot and your computer are connected by Bluetooth. Good work. Next, look at the LEGO Scratch commands on the left-hand side of the screen. We find a pink command which says move straight 0 for 10 centimetres. Click on this and bring it up underneath the yellow When Program Starts command. Change the 10 centimetres to 23 centimetres. To see if our command teaches our robot to move from our pretend Earth to a position alongside our pretend moon, click on the round green circle with the white triangle at the bottom right of your screen. What happens? Oh dear, nothing happens. Click on the red circle to stop the program running. We have not told our robot which motors we want it to use when it moves forward. Find the command which says set movement motors to A and B. Place it between the yellow and the pink commands in your list of instructions. Now check your robot and see that the motors are in fact plug into slots E and F on your robot. Change the A plus B to E plus F by clicking on the E and F rectangles in the hub diagrams that we see when we click on the A plus B. So now we have the correct command. Good. Now start our robot again by clicking on the green circle at the bottom right of the screen. Hurrah! Your robot moves forward. However, you will notice that the green circle at the bottom of the screen is still rotating. This is because we've not put a stop command at the end of our program. Find the yellow Stop All command. Add it to the end of your program. Click on the All and select the And Exit Program option. Have another run. This time you'll note there is no longer a circle rotating on the green Start command at the bottom right of the screen, and your program has ended correctly. Excellent. Your robot will probably look something like this. Next, we need a command to send your robot in a curved path around our pretend moon. Again, find our pink Move Straight for 10 centimetres command. Move it just under our previous similar command. This time, however, click on the straight 0 and you will see an arrow within the circle. Move this in a clockwise direction so the tip of the arrow goes to your right until the number reaches about 40. Why 40? Well, we don't know what number is a good one, so we just guess. 40 seems as good a number as any other number. And we've got to choose a distance as well. What distance should our robot move? Again, let us guess a distance. Change the 10 to 40. We can always change it again later and have another run if we are wrong. Now, try a run. Well, that looks good, apart from the fact our robot seems to have ended up heading out towards Mars. Change the turn number to 50. And the distance number to 80. Let us run again. That looks much better. We need to go a bit further in distance because we need the robot pointing back to Earth, so we can use the move straight 0 for 10 centimetre command to end up back at Earth. We would have to guess or measure the number to replace this 10. Because this is a challenge, we are not going to tell you the exact instructions to get your robot safely back to Earth. Experiment. Change each of the numbers in your command and see how they change where your robot goes. Now, have fun finding out how to teach your robot how to leave your pretend Earth, go around your pretend moon, and safely back onto your pretend Earth. Let us see if you can solve this challenge all by yourself. Now, there are many different correct answers to this challenge. A correct answer is one that lands your robot safely back on Earth. If you're in a class, probably each member of the class may have a different program. Having different programs is fine. Take a look at the other solutions and see how they differ from yours. Can you change your program and still have your robot land safely back on Earth? At the web page linked below, you can see some extra ways that other students in the past have sent their robots around the moon. Some are quite fancy. Have fun, see if you can change your program to make your robot go around the moon like theirs. Good luck and have fun sending your robot around the moon.